Good evening, everyone. Welcome to this Embedded System Design Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. And today topic is about introduction to embedded system design. First, I would like to welcome the early comers first. Good evening, Ankit Jain. Good evening, Surya. Good evening, Guru Prasad. Good evening, Electrocode. Shantesh, good evening. Srinivasan, good evening. Chant, Dharani, good evening. Amar Singh, good evening. Shreyas, Darshan, Vinayak, Saif, Pooja, Nesaraj, Gokul, Sumit, Siddharth, Venugopal, Mukund, Rao, edited videos, and Sanjay, Sahib, Dada Sahib, and Ankita Kumari, artist lover, and Velu Balaji, Shubham. So good evening to everyone. Thank you so much for your time and thank you for your presence. No need to type present sir on the chat box. I'll give you the instructions like when to mark the attendance form. Okay, so let's go for the session. So this session, I will give you I will tell you why 30 days challenge, why we have keep on this session for 30 days. Okay, for any habits, you need to form a habit, you need 30 days. Okay, if you do the if you do it that on a consistent basis, you will develop the habit. So this session I will have both the skill set as well as the mindset. We will dedicate one slide for mindset, so that we want you to develop both success mindset as well as the skill set. Okay, so it's a combination of both skill set as well as mindset lesson. And if you follow this session for 30 days, definitely you will develop the habit of self learning. Okay, so that's the key thing for this 30 days challenge. And so what you will learn on this 30 days. Before that, I would like to ensure whether I'm audible. And if I'm audible, just type audible in the chat box. I'll go through the chat and it will take 20 seconds or 30 seconds of time to reach me. That will be a delay. Okay, and if I'm audible, just type audible in the chat box. I'll go through your chat, and some of them, Vairamuthu is telling that sound is low. Okay, so am I audible? Thank you, Shahid. Thank you, Kumar. Thank you, thanks Sunil, and thank you, Diyanshu, and so thank you so much. Okay, thank you so much. Okay, so what you will learn on this 30 days. Okay, so we have split it 10 days for each sections. For embedded system design for 10 days, and for IoT 10 days, and for PCB design 10 days. If you have attended our previous masterclass session, our embedded system design, so we have collected some topics from embedded system design masterclass. And IoT masterclass, we have taken the 10 topics excerpts. We have taken 10 excerpts, and PCB design masterclass. Okay, so once you go through this 30 days, you will be able to design your own microcontroller board. I'm sure that you will be able to design your own microcontroller board, and you could write your own applications on embedded system design, and you could develop the IoT applications. Okay, so the first 10 days is on embedded system design, where we cover up. So today's session we will be covering up introduction to embedded system design and how to choose the right processor for embedded system design. So that we'll be covering up today. And tomorrow class we will be covering up the challenges in embedded system design, and what are all the components in embedded system design, and what is AUTOS, how AUTOS plays a major role on embedded system design. So that we'll be covering up on day 2. On day 3, we will be covering up the 8051 architecture. Okay, so the first 3 days will be of theoretical sessions, and from day 4 is practical sessions. Day 4 is introduction to Kale software, how to create a project and how to download the program on the microcontroller. And day 5, how to interface a switch and a relay and UART programming. Step by step, I will explain the code step by step. And so it's on day 5. And day 6 is a simple project, a Bluetooth based home automation. Okay, so I just increase my volume. Okay, so day 6 is about Bluetooth based home automation. Okay, so how to control lights and fans by using your mobile phones. We'll be using a HC05 module to interface with an 8051 microcontroller board. Okay, so day 7 we will be covering up two architectures. One is the ARM7 architecture and another is the Cortex M4 architecture. On day 8, again, a simple project by using ESP8266, like IoT-based weather monitoring station. And day 9 is about Cortex M4, how to blink an LED, how to interface switch and UART. And day 10, again, is a project, temperature monitoring using LoRa modules, okay? So this 10 days, you will be having three projects. We'll be covering up three projects. I will show you the demo on the hardware. I will explain you the code on the C program. Okay, so the first 10 days is of embedded system design. If you want to much more details, like we have caught up on embedded system design masterclass, like where we have caught up 8051 architecture for 5 days and PIC architecture for 5 days and ARM7 architecture for 5 days and Cortex M4 architecture for 5 days. So we also have 5+ project on this course. So if you want, you could enroll, and we have an offer, like I will tell you on the end of the session. Okay. So the next 10 days is about the Internet of Things. So the first 5 days, we'll be covering up the introduction to IoT and components and the communication protocols and different types of IoT clouds. But this 10 days, we will be covering up only the ThinkSpeak cloud. We'll on day 13, like we'll be covering up the introduction to ESP32 and Node MCU and how to send data to the cloud, to the ThinkSpeak cloud. That we'll be covering up on day 14 and day 15. On day 16, how to develop a machine learning model on the cloud. Okay, so how to deploy a machine learning model on the cloud. And day 17 is again LoRa module using ESP32. And day 18, how to send data to the Google Sheets using IFTTT, and how to send alerts like SMS or email. That will be covering up on day 18. So day 19 is about the real-time video surveillance by using ESP32 cam and blink app, and day 20 is about the predictive maintenance of duct fan. Okay, so all this day 16 to day 20 is all about projects. So you could add these projects on your resume. So on going through this course, like you could add minimum like 8 projects on your resume, and you could develop your own microcontroller board. So that's that is from day 21 to day 30. So I'm going to teach you Cadence Allegro, how to install Cadence Allegro, and how to draw schematics, and how to make footprints, and how to design the 8051 development board like this. Okay, how to design the 8051 development board like this, and where to fabricate the PCB, and how to like the same board we are going to develop. How to design power supply, and how to design the programming module, and how to design the ports, okay, and how to design the UART. So we'll be going through how to make schematics, how to create schematics library, and how to make PCB footprints, and how to place components, and how to make a legend, and how it's a 2-layer board. So how to do a top layer routing and bottom layer routing, and how to add drill shots, how to create Gerber layers. Okay, finally, how to fabricate the board. So these we will be covering up on the 10 days. Okay, from day 21 to day 30. So I'm sure that once you complete the session, like you can design your own microcontroller board like this, and you could write the program for the microcontroller, and you could download the program. You know how to download the program, how to program the chip, and how to write the IoT applications, how to send data to the cloud. So everything you will be familiar of. Okay, so I assure you, like to deliver the maximum. So hope you have a great learning on this 30 days. Okay, if you are ready to learn, just type RTL in the chat box. Are you ready to learn? Okay, just type RTL in the chat box. No need to type present sir in the chat box. I will give you the clear instruction where to submit your attendance. Okay, if you're new to this, I will give you the clear instruction how to do that. My voice is slow. Satyam is saying my voice is slow. So I want to ensure, guys, like whether my voice is audible or not. I'll go with the majority. If my voice is audible, just type audible in the chat box. If my voice is low, just type low in the chat box. Okay. I want to ensure that before we proceed, I want to ensure that my voice is clear or not. Just type audible in the chat box if my voice is audible, or low in the chat box if I'm waiting for a chat. I'm just receiving the RTL command in the chat box. Thank you so much for your energy, and just type audible. Thank you, Ramakrishna. Thank you. Thank you, Satya. Thank you. So majority is audible. Sahib is audible. Gautam and Piyush, everyone is telling audible. Those who are telling low, please check your speakers. Okay, so only one low is there. Okay, little low. Okay, okay. Anyhow, I will try to increase my voice. Okay, let's proceed. So I'll give a short introduction about Pantech just for 2 minutes and about the introduction about me, and then we can go for the session. Okay. About Pantech, like Pantech was started in the year 2004. Like we basically, it was founded by 4 founding members, and we basically manufacture lab equipments for engineering colleges. We supply microcontroller boards, DSP boards, and FPGA boards. We do also manufacture power electronic trainer kits, and we also manufacture an EEG headset called BrainSense, the only consumer grade EEG headset in India. Okay. We have partnered with a company called Neurosky, and you could visit our website for more details. You could visit our website pantechsolutions.net. Our vision is to help 10 million students to learn the technology in an easy way. So far, we have trained 1 lakh plus students, 2 lakh plus students on YouTube. And this year, we have a target of training around 8 lakh plus students. So to reach up 1 million students first, to train them on the latest technology. So that's our vision. And about me, my name is MK Jivarajan. I complete my bachelor degree in the year 2002 from Government College of Engineering, Bagur, and my master's in the year 2004 from College of Engineering, Guindy. I'm basically from Applied Electronics, and my primary expertise is on microcontrollers, DSPs, and FPGAs. I used to work on various microcontrollers, like I'm responsible for the research and development team in Pantech. So these are the boards like which I have worked and I have designed. If you check the microcontroller boards, like almost we have designed like 30 plus products on microcontroller boards alone, like 8051 boards and like big 8085 boards, ARM7 boards, and Cortex M4 and PSOC. I have worked very closely with various microcontroller manufacturers like Microchip, Texas Instruments, Analog Devices, and in FPGAs I have designed boards on Xilinx and Altera, and DSPs, Texas Instruments and Analog Devices. And so this session is about sharing my knowledge with you. If you want to connect with me, you could connect me on LinkedIn. Okay, I will share you my LinkedIn link here. Give me a moment. I'll share you my LinkedIn link. You could send me a connection request. I am happy to connect and happy to help. Okay. So I just share my LinkedIn link. I will put it on the chat box. Okay. So I have shared my LinkedIn link in the description box. If you want to connect with me, I'm happy to connect and happy to help. Okay. So that's all about me. I will coming to the announcement. The attendance link will be available at 9 p.m. or 9:15 p.m. So they will instruct you on the chat box. So minimum attendance required to get a free e-certificate is 27 days. Okay. Out of 30 days, we wait off 3 days. You may get a waiver for 1 or 2 days again, like 24 or 25 days. But please be ensured that you present on all the 30 days just to develop the learning habit. Okay. The key thing is to develop a learning habit. So attendance link will be valid for 1 hour of time. For the first 3 days, we will be liberal. After 3 days, we'll be closing within 1 hour of time. So attendance link will be valid just for 1 hour. You have to go through the video and you have to fill the attendance. Okay. For internship candidates, no need to fill the attendance form. All you have to do is after watching the video on the portal, Learn portal, you have complete and continue on the top. Just press the button. So that will mark the attendance, and once you complete all the course, the certificate is auto generated in the portal itself. Okay. So for some sessions, I will be using the recorded video streaming if I am not able to present it on live, or to enhance the learning experience. For if it is a lab class, then I will go with the recorded video streaming to enhance to improve the learning experience. Or if I am stuck up with some meetings, or in that case, I'll be using a recorded video streaming to live the chat. Okay. So probably you will be having the class on Sunday also, just to develop the habit. Okay. Anyhow, I will discuss with my team, but probably you'll be having the classes on Sunday also. So PPT and source code downloads is available only for the paid participants, but the PPT in PDF format, I'll be sharing through the Facebook group. I will provide the Facebook group to collect the PPTs and collect the gifts. We also have a lot of gifts. One for those who are doing the assignments and submitting the assignments on time. both the skill set activity as well as mindset activity. You will get gift like pen drives, and you will get vouchers, 1,000 rupees voucher for you as a GPay. Please join the Facebook group and submit the assignments. Okay, so you could collect your gifts at free of cost. Okay. So coming to the job opportunities, like if unless you have electronics in the market, you will be having a demand for embedded system design. Okay, and more and more devices are getting connected now. IoT, like we have billions of devices is getting connected now. There are a lot of job opportunities. If you want to make your career on embedded system design, this course will be the right fit for you. I am sure that this course will be the right fit for you. You could, if it is not useful, like you could tell me on the chat box. Over the period of time, you could communicate on LinkedIn, or you could communicate through the Facebook group. Okay, I will be active on the Facebook group as well as on LinkedIn. And coming to this entrepreneurship, like you could also design your own products and you could sell. If you don't have money to startup, still you could use the crowdfunding platform to design your product. All you need is an idea. Okay, and you should have a skill set to develop the product. So this is an example of a site called Kickstarter, like where they have showcased the simple product, design a simple product for called LED tester, and they have sold for 2 lakh rupees. Okay, so there are companies which has raised 6 crores in 10 days. Even in companies in India has raised 6 crores in 10 days. It all depends upon the idea and the product. But you could explore these sites called Kickstarter.com or Indiegogo.com or the crowdsupply.com, where you could design your products, electronics products, and you could sell. You could pitch the products on the portal. Okay, on the crowdfunding portal. The other option is to do freelancing. Like if you know PCB design, like you could get money by freelancing, like for how to create footprints and to do PCB layouts. Okay, all you need is practice. Don't wait for the companies for the experience. You just practice, have a lab at your home, and practice will make you perfect. Okay, and you could start earning your money. So let's start the session. Thank you so much. Only the day one, like it will be of more time for introduction. From tomorrow onwards, the introduction session will be only for 5 minutes of time. So we could straightly jump to the session. Okay, so since it's first day, like the introduction session is taken nearly around 15 minutes. So there will be an extension of 15 minutes. Like today, the session will take 9:30 to 9:45, but tomorrow, like we will stick to the plan. So the session will be for 45 minutes to 1 hour of time. Okay, so we'll close the session within 45 minutes to 1 hour of time. So today we will have some extension. So today is about what is embedded system design and how to choose the right processor, because there are a lot of processors in the market. How to choose the right processor for the embedded system design, that we are going to see today. For every 5 minutes, I'll go through your chat. If you're not clear with the chat, if you are not clear with the topic, just type repeat in the chat box. If you are clear, just type clear in the chat box. For every 5 minutes, I'll go through the chat. Okay, in between time, I won't go through the chat. I won't look into the chat. So if you are not clear with the topic, just type clear in the chat box. Repeat in the chat box. If you're clear, just type clear in the chat box. I'll go with the majority. Okay, so let's start the day with a mindset lesson. So I'm dedicating this slide for my mentor, for my virtual mentor, Bob Proctor, who passed away just 7 days back. Okay, he's my virtual mentor. I am the paid customer for him. Like I used to go through, I had done a lot of programs which changed me, like which increased my, which I have changed my mindset. Okay, so I want to repeat his statement. Okay, decide what is that you want. Okay, this is a statement by Bob Proctor. Decide exactly what is that you want. You want money, or you want fame, or you want job. Decide that first. Okay, so the first thing of today activity is to have a definite goal. So if you have attended my previous sessions, like I have repeated the same thing, but I don't know how many of them have practiced so far, but have the habit of writing the goal on daily basis. Okay, the first thing is to have a definite goal. Goal without a deadline is a dream. So you should have a deadline for your goals and keep working towards the goal on a positive attitude. I will give you a clear explanation of what is positive attitude tomorrow. So tomorrow class. So prepare a goal card and write your goal on a spiral binding notebook on a daily basis. Okay, when you write the goal by using pen, so your mind communicates to the hand, so the neurons will get communicated, and your eyes will see the will see the goal which you have written on the spiral bending notebook. So it's a feedback mechanism of programming your subconscious mind. So have the habit of writing the goals at least twice. I'm writing my goals on a daily basis on twice a day, before I go to bed and after I wake from the bed. Okay, so at the early morning I used to write the goal, as well as when I'm going before I sleep, I used to write the goal on my spiral bending notebook. So I want you to do the same thing. And I'll also provide you a video at the end of the session, audio at the end of the session, called A Stranger's Secret. I want you to listen to this audio, okay, and share your feedbacks on the Facebook group. And so you will also get a pen drive for the task. I will give you a clear instruction on the Facebook group. So if you're not available, if you're I will share you the Facebook group through email or through the chat box. I'm not sure, like, whether my team is sharing it on the yes, they're sharing it on the chat box. Okay, you join it on the Facebook group. So I'll share you audio file called Stranger's Secret. This audio is from 1960s. You hear it at least once, so that will change your life. So let's go for the session. So if you're ready to learn, just type RTL in the chat box. Just type Vamshi Vemlo, like the PPT will be shared. PPT will be shared on the Facebook group, but source code is available only for the paid participants. Okay, only for the paid participants. But on going through the video itself, you could replicate the source code. Definitely, I'm sure for that. Okay. So if you don't have a Facebook account, Jan, like if you don't have a Facebook account, I will also share the PPT PDF through email. Okay, so please ensure that the email reaches the inbox. If you don't find the email, please check your spam. It may be on the spam, so you have to move it to the inbox. So thank you so much, Sharon, Teja, Vinayak, and Arvind, Tejas, Navneet, Hari, and Jayan, and Shubham, Indumadi, Shakshi. Thank you so much for your comments. Let's start the session. So what is embedded system? Okay, so embedded system, it's a combination of both a hardware and a software with some mechanical parts to perform a specific task. So that is an embedded system. For example, you take a personal computers or mobile phone, it is not an embedded system. It is a general purpose system. An embedded system is a system which performs only the specific task. Okay, for example, printer, mouse, and digital camera. These are all an example for embedded system. So I just repeat. Okay, embedded system, it is a combination of hardware. The hardware is the electronic components. Okay, and the software. It's a combination of both hardware and software, and it may also have some mechanical parts like gears or motors. Okay, and to perform a specific task. So that is an embedded system. If you take a PC, personal computers, or general these are all general purpose systems, and they are not called as an embedded system. An embedded system is a system which do only the specific task. Okay, so printer, mouse, and digital camera, these are an example for embedded system design. Okay, so coming to the classification of a real-time embedded system. Before that, I will tell you like what is real-time embedded system. Okay, if the embedded system complete the task within a specific amount of time, then it is called a real-time embedded system. Real-time embedded system design. Okay, in that you have two classifications. One is the hard real-time, and another is the soft real-time. Okay, hard real-time means like missing a deadline may cause an havoc. For example, a nuclear reactor. Take an example for nuclear reactor or aerospace application or an aircraft. If the embedded system misses a deadline, that may cause an havoc. So many people will die. So that kind of system is called hard real-time systems. Okay. The other thing is called soft real-time systems. You may have a deadline, but it will degrade the performance. For example, a gaming device, okay, any VR device, virtual reality device, missing a deadline may degrade the performance of the system. So that is soft real-time. Okay, I just repeat, real-time embedded system means that system, the embedded system should complete the task within a specific amount of time. That is called a real-time embedded system design. Okay, hard real-time means, like hard real-time system means if the embedded system misses the deadline, it may cause an havoc. That kind of system is called a hard real-time system. Soft real-time system, missing a deadline may degrade the performance. It may be a gaming device. Okay, so embedded system is a device which performs only the specific task. So that is an embedded system design. In that, we have two cases, hard real-time and soft real-time. So coming to the processors and controller, okay, there are different types of processors and controllers in the market. We have microprocessors, we have microcontrollers, and we have digital signal processors. We have CPLDs, we have FPGAs. Apart from this, we also have microprocessors like general purpose microprocessors like Pentium 4, AMD, and Intel Celeron. Okay, and we also have ASIC application specific integrated circuits, and we also have system on chip, the chips which was used on the mobile phones. Okay, those are called system on chip, like Qualcomm Snapdragon is an example of system on chip. So we have different types of processors and controllers. Only if you know the difference, then you could choose where to use the right processor, and where to use the microcontroller, and where to use DSP, where to use CPLDs and FPGA. So we are going to cover up the difference between the microprocessors and the microcontrollers, microcontrollers and the DSPs, DSPs and FPGAs. Okay, going to cover up the difference. There are a lot of manufacturers. For each processor and controllers have a lot of manufacturers like Dallas, Philips, NXP, Renesas, Freescale, Texas. These are all the manufacturers. They have category like 8-bit microcontroller, 16-bit microcontroller based on the mathematical calculations, and DSP processors is really dominated by Texas Instruments, Analog Devices, and Motorola, and CPL and FPGA. Xilinx and Altera, and Intel, AMD, and GPUs is dominated by NVIDIA, okay, and ASIC, application-specific integrated circuits, and SoC. So these are all the different types of processors and controllers. So before I go to the next slide, I would like to ensure like whether you are clear with these 3 slides. Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'm waiting for a chat. The chat may reach me out within 10 seconds of time. Matrices is asking for repeat. Okay, I'll go with the majority. If it is clear, just type clear in the chat box. If you want me to repeat, I will just type repeat in the chat box. I'm waiting for your chat. One repeat I got. Mahavir Singh is clear, and clear. Okay, and Krish clear. So repeat. Okay, repeat. Some is asking for repeat. Okay. So I will repeat from this real-time embedded system design. Okay, real-time embedded system design means like embedded system which completes the task within a specific amount of time. That is called a real-time embedded system. Okay, in that we have 2 categories. One is the hard real-time, another is the soft real-time. Hard real-time will create an havoc if the embedded system design misses the deadline, if it does not complete the task within a particular amount of time. That causes an havoc. That is called hard real-time. Examples: a nuclear reactor, aircraft. These are the examples for hard real-time systems. Soft real-time system means like it may degrade the performance. Mobile phones, the gaming device, not mobile phones, the gaming device or virtual reality device. Okay, if it misses a deadline, and there will not be a big havoc, but it degrades the performance. So that is called soft real-time. There are a lot of processors in the market, like microprocessors, microcontrollers you have, and DSP processors you have, digital signal processors. You have CPLDs and FPGAs. You have CPUs like general purpose processors like Intel, and GPU from NVIDIA, graphic processing unit, and ASIC, application specific integrated circuits, and SoCs. Only if you know the difference between those processors, you could decide where to use what. Okay, so let's start with the microprocessor. The microprocessor like 8085 or 8086, even the processor which is used in Raspberry Pi is a microprocessor, where you have to interface everything externally, like the data memory, the program memory, and the interfaces like UART and the parallel peripheral interface. You have to interface externally, like 8086 and 8085. You have to, everything will be an external chip. You need to do a printed circuit board for integrating all those components. Okay, so that is a microprocessor. Whereas in microcontroller, everything is on chip. Okay, on a single chip, you have the CPU, the LU unit, and you have the program memory, you have the data memory, you have the interface like the timers, ADC, control area networks, and the parallel port, UART. Everything is on a single chip. Okay, so that is a microcontroller. Okay, whereas microprocessor, everything is external. You have to connect with to make a PCB board, and you have to connect to the microprocessor. Whereas microcontroller, everything is available on a single chip. Okay, so that is a microcontroller. Coming to the DSPs, digital signal processor, these are the microprocessors specially designed for doing a complex mathematical calculations. Okay, it could DSP processor can do a complex mathematical calculation. It has the capability of doing floating point like calculations as well as the fixed point calculations, and it is specially designed for hard real time. Okay, for hard real time systems, and it can process infinite continuous data streams if you grab a video from a camera or an audio stream from a microphone. Okay, so you will have a continuous data streams. So it has a special interface to interface with audio codecs and video codecs, so that it could do a complex mathematical calculation inside the chip. So that is the DSP processor, digital signal processor. It has a MAC capability, multiply and accumulate in a single instruction cycle. Okay, so DSP processor is meant for mathematics. Okay, if you want to do a complex mathematical calculation, then you could choose a DSP processor. Whereas microcontroller, if you want to implement a simple applications like a simple door lock, then you could go for a microcontroller. But there are some microcontrollers which also has a DSP engine on it, like the Cortex M4, the ARM7 has a DSP port, simple DSP, where it could process a simple algorithms. But this DSP processor is meant only for the audio applications and for video applications where you have complex mathematics involved in it. Okay, so is that clear, like the difference between the microprocessor and the microcontrollers and the DSP processor? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay, so I'm waiting for a chat. So whenever you need precision and whenever you need to like low cost saving and smaller in size and low power consumption, you could choose a DSP processor. Whenever you need large memory, like where power is not a constraint, then you could go for a general purpose processor like Intel 4 or like that. Okay, so thank you so much. A lot of people has typed clear. For those who are repeat, please go through the video again. The video will be available for 3 days. After that, it will be removed from YouTube. Okay, so I forgot to tell this. The video will be available on YouTube only for 3 days. After that, it will be removed from YouTube. You have to go through that before. You have to go through the videos before 3 days. Okay. So basically, these processors are built on the architectures. Like you have basically two kind of architecture is there. One is the Harvard architecture, and another is the von Neumann architecture. Okay, the Harvard architecture, the CPU is connected with program memory and data memory by using different address bus and different data bus, so that it could simultaneously fetch the data memory and simultaneously fetch the program memory. Whereas for the von Neumann architecture, the CPU is connected with the program memory and data memory by using the same address bus and data bus. Since it is connected to the same address bus and data bus, you could either fetch program or data, or you could either fetch data memory. Okay, you cannot do it simultaneously. So that is the disadvantage of von Neumann architecture. Most of the DSP processors and most of the latest microcontrollers are from the Harvard architecture, and they also have super Harvard architecture. Okay, so but basically these are the two architectures which dominates the market: microprocessor and the microcontroller market, and the DSP processor market, the Harvard architecture and the von Neumann architecture. Okay, so Harvard architecture, it could fetch the data from the data memory and the program memory simultaneously. Whereas the von Neumann architecture, it could either fetch program or data. Okay, so that's the difference. Like, so efficient mathematical calculation will be done on the Harvard architecture. So coming to CPLDs and FPGAs, CPLD stands for complex programmable logical devices, whereas FPGA stands for field programmable gate arrays. Okay, CPLD is control oriented. So wherever you use microcontroller, you could use CPLD, complex programmable logical devices. Wherever you use a DSP processor, you could use a field programmable gate arrays. Okay, FPGAs, you could use FPGA. It is data path oriented. It is meant for FPGAs is meant for complex mathematical calculations. Like it could do complex. It could solve complex mathematical calculations. CPLD. Wherever you use microcontroller, you could use CPLD. The one advantage of these devices is it is reconfigurable. It means it's tailor-made. You could customize the architecture. Whereas the microcontroller and DSP processor, you cannot customize the architecture. I want to clear this point again. Okay, CPLD and FPGA. CPLD stands for complex programmable logical devices. It is control oriented. Okay, wherever you use microcontroller, you could use CPLD, but CPLD has an advantage over the microcontrollers, where in CPLD you could customize. You will have the GPIO pins. So you could customize any GPIO pins and any number of UARTs you want. For example, if you take a 8051 microcontroller, you have a single UART. Okay. If you want two UARTs, then the next option is you have to go with a softer UART. If you want more than 2 UARTs or 3 UARTs, then there is no possibility on 8051. Whereas in CPLD, even if you want 5 UART, you could have 5 UARTs. You could design 5 UARTs on CPLD. You could customize that on CPLD. So you have to write the code on the hardware description language. But today, like, you could also write the code on C language, and you could also write the code on graphical programming like MATLAB. You could even download the MATLAB codes by using a cross compiler that you could develop the HTML and finally download the code inside the Fpga. Okay, so Fpga is also reconfigurable. Okay, is this clear? Is this clear whether the CPLD is Daniel is asking for repeat? Daniel Feroz is asking for. Is that clear? CPLD and Fpga is clear. Just type clear in the chat box, else I will repeat the chat. UART stands for Universal Asynchronous Receiver Transmitter. So we have a detailed session on that. Okay. It's a serial communication device. I'm waiting for a chat. Avinash is also asking for repeat. Okay. Avinash Shabi is also asking for repeat. Is also asking for repeat. Is that clear? I'm waiting for a chat. I will go with the majority because we have like today, like the time is, we need a lot of time to cover the topics. So a lot of people is asking repeat. Okay, so I will repeat the topic. Okay, see, I will repeat from the DSP. So DSP processors, or I'll go slow. Okay, DSP processors are meant for mathematical calculation. If you want to implement a complex mathematical calculation, then you have to go for a DSP processor, and it has special interface like to interface with audio codecs and to interface with video codecs. Okay, because audio codecs and video codecs will generate continuous data streams, so microcontroller has no capability to handle the data from audio codec as well as from video codec. For example, you take a CMOS image sensor, okay, camera sensor. So the camera will give you 40 frames per second. It means 40 still images. You will get 40 still images per second, where you have to process those 40 still images. Microcontroller has no capability of doing that mathematical of doing the matrix. Okay, because again, the image is nothing but a matrix. Okay, it will be in a matrix format. So it cannot handle the complex mathematical calculation, whereas DSP processor can handle mathematical calculations, complex mathematical calculations. So if you want a low cost and smaller in size and low power consumption, then you could choose a DSP processor. If power is not a matter, then you could go for a microprocessors, complex microprocessors, like the chip like or Intel processors, Intel GPU, where size is not a constraint and space is not a constraint and power consumption is not a constraint, where you could have a wall-mounted power supply. In that case, you could go with the general purpose processor itself. Okay, so where power is a constraint and where cost is a constraint, smaller in size, lower power consumption, and it should be battery operated, in that case, you could choose a DSP processor. Whereas coming to basically it is made up of the every processor is made up of basically made up of two architectures. It either have von Neumann architecture or the Harvard architecture. Okay, so von Neumann architecture, the CPU is connected to the program memory and data memory by using the same address bus and data bus. Okay, since it is having same address bus, so you cannot change the bus width. Whereas here in Harvard architecture, the program memory uses a different address bus and data bus, and the data memory uses different address and data bus. So it can simultaneously fetch the program as well as data, and it could do a efficient way of mathematical calculation can be done on the Harvard architecture. Most of the DSP processors are Harvard architecture. Okay, and even the latest microprocessors like the Cortex M4 are the Harvard architectures. Some of the microprocessors are von Neumann architectures. Microcontrollers and microprocessors are von Neumann architectures. So they use the same address bus and data bus. Okay, so coming to the CPLDs and FPGAs. CPLD stands for Complex Programmable Logical Devices. Microcontroller, for example, if you take an example for 8051 microcontroller, if you have a dedicated, there will be a pin dedicated for UART. UART is for serial communication. Okay, for every peripherals there is a dedicated pin. You cannot customize a pin. Whereas CPLD is just like a tailor-made shirt. You could customize the IO pins. The IO pins will be in general IO pins. If you want as a UART pin, serial communication pin, you could use as a serial communication pin. If you want that as a SPI pin, like a serial peripheral interface or I2C communication, you could have, and you could have any number of UARTs, 2 UARTs or 3 UARTs, 4 UARTs. You can customize the architecture inside. Okay, inside the CPLD, you can customize the architecture. Whereas in microcontrollers, you cannot customize the architecture. The FPGA, DSP processor, you cannot customize the architecture. Whereas in FPGA, you can customize the architecture. It's tailor-made. Okay, and wherever you use DSP processor, you could use FPGA. It's data path oriented. Okay, control oriented. CPLD is for control oriented. Okay, like wherever you use microcontrollers, you could use CPLDs. So this is how a CPLD architecture looks. Logic blocks, it has logic blocks where you could implement any complex Boolean functions like Karnaugh map implementations or Boolean equations. If you want to implement any truth tables, you could use logic blocks. And IO blocks like where the IO pins will be connected, and clock routing to give clocks to these logic blocks, and routing matrix to interconnect these logic blocks. Okay, so this is the CPLD architecture. Whereas in FPGA architecture, if you see the difference between the CPLD and FPGA, FPGA has memory, FPGA has multiplayers to do the DSP capability, and it also has the core, the processor core. Okay, processor core means the ALU unit. Okay, there are two types of core here. One is the soft core processor, the other is the hard core processor. The soft core processor means the core is created by the software, by the hardware description language. Okay, whereas the hard core processor means the core is fabricated on the fab itself. Okay, on the fab, on the manufacturing itself will fabricate the core. Like PowerPC is one example for the hard core processor. Microblaze is an example for the soft core processor. Okay. FPGA has the logic blocks, the IO blocks, the clock routing and routing matrices. Everything is same as like CPLDs. The only difference is it has memories, it has multiplayers, and it has processor cores. Okay, processor core, hard core and soft core. Is that clear? Is that CPLD, the difference between the CPLD and FPGA is clear? I'm waiting for a chat. Designer Boutique is asking, what if I have a doubt? Please join the Facebook group and you can post that doubt there. Definitely I will reply you back. Okay, you could also connect me on LinkedIn and you could ask me questions. Like I'm very active on LinkedIn, and like I'm waiting for a chat. If the difference between CPLD and FPGA is clear, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'll go. We will have a Q&A session at the end of the sessions. Okay, we have Q&A, so you could ask the questions at the end of the session. Please don't like, you could ask me questions at the end of the session. I will dedicate 5 to 10 minutes of time for Q&A. No problem with that. Thank you so much. A lot of people has typed clear. Thank you. Those who are asking for repeat, I'm really sorry. Please, the video is available there on YouTube. So you just go through this. This is not a complex thing. Okay, you could easily learn it very easily. Okay, so FPGA, again in FPGA, based on the technologies, like there are different types, like based on the programming technology, like SRAM is the reprogrammable technology. Like when you power off, the program will go off. Okay, most of the FPGAs are based on SRAM based technologies. Flash technology is non-volatile. It's non-volatile. Like even when you power off, and the program will be there. Okay, like Spartan 3AN is an example where N stands for non-volatile. It's a flash-based technology. Antifuse is a one-time programmable chip. Okay, you could program the chip only for once. So that is an antifuse. So based on that, you have different type of FPGA technologies out there. And coming to DSPs and FPGA. Okay, so I'm going to give you a clear example, like when to use, what is the advantage of going with FPGA over a DSP. Okay, so if you take this example, a DSP processor is sequential because it's a C-based programming, so it will execute the instruction one by one. So if you do a simple FR implementations which has 256 clock cycles, DSP will take 256 clock cycles. Okay, whereas on FPGA FPGA supports parallelism. The language itself will support parallelism. If your algorithm is parallel, FPGA can complete 256 operation in one clock cycle. So you get higher performance when the algorithm is parallel when you compare with the DSP. I just repeat. Okay, DSP is sequential because it's based on C language. It's sequential, like it executes instruction step by step. So it needs 256 clock cycle. Whereas FPGA, it's parallel. It can execute simultaneously. Okay, if the algorithm is parallel, then you could choose FPGA has an advantage over DSP. It can complete the instruction with one clock cycle. Okay, clock cycle is the time taken for completing the instructions. So the 256 operations will be completed in one clock cycle. Okay, so that is FPGA. And coming to when to use a DSP in FPGA, whenever you need a higher performance, okay, whenever you need higher performance, whenever you want to implement a parallel algorithm, or whenever you want to customize for speed and cost, whenever you want to reduce the number of chipsets. I will show you one example on the next slide. Whenever, if you want to reduce the number of chips on the embedded system design, you could go with FPGA. Okay, so this is an example of using a DSP board. So this board has a Texas Instruments DSP processor, TMS320C6711 series. If you check the components inside these boards, you have a power supply, and you have the you have the power supply, like you have the audio codec, okay, and you have the Ethernet MAC, address decoding unit, memory controllers, SRAMs and SDRAMs, and display controllers, and UART. Okay. So the power supply IC, you cannot keep this component inside an FPGA. Okay. So audio codec will have analog signal processing. So that thing also you cannot keep it inside an FPGA. These connectors cannot be kept. And SRAMs and SDRAMs, okay, they need more silicon area. So you cannot keep these things inside an FPGA. So the rest of the part, everything can be incorporated on a single FPGA. Okay, so that is the rest you could interface. The power supply, the audio codec, and SRAMs and SDRAMs, you could interface. Okay, so the power. So by this way, you could reduce the number of chips when you design with FPGA. So I just repeat: if you take this board, if you take this DSP board, you have a Texas Instruments DSP processors, where you have a power supply unit here, an audio codec will have analog signal processing, so that cannot be kept inside an FPGA. And SRAMs and SDRAMs, okay, will have more silicon area, so that cannot be incorporated inside an FPGA. And display controllers and kind of LC for connectors, okay, so these connectors you cannot keep inside an FPGA. So the rest of the parts, everything you could incorporate inside a single chip. Okay, you could customize the chip, and you could add the part externally, the audio codec. So by this way, you could reduce the number of chips, you could reduce the complexity of the schematics, and you could reduce the complexity of the layout. Okay, so that will give you the higher performance. So in order to overcome this, the DSP manufacturers, they came up with multi-processor. They came up with a concept called multi-core processor. So before that, like I would like to ask whether if it is just type, if you are clear with this topic, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay. If you're clear, please don't like the attendance link will be valid for even after the session. So you could fill even after the session, like it will be valid for 1 hour of time. So the key takeaway is the knowledge. Okay, it's not the certificate. Okay, it's the knowledge. Okay, so if it is clear, just type clear in the chat box. If it is clear, just type clear in the chat box. Please don't spam the chat for asking for attendance. The link is already there. And thank you so much. Thank you so much for clear, for this, Hitesh and Vinay, Deepak, Saravana Kumar, Pavan Kumar, Saravanan C, thank you, Karthik Karke, Deepak, thank you so much. Prof Thoughts is asking for repeat, and Dhruv Sharma is also asking for repeat. So please go through this video. Okay, I'll go with the majority because we don't have time. So multi-core processor, like multi-core processor is having more than one core and a single package. Okay, one processor. Core is nothing but a processor, like the ALU unit. So today, like if you take your mobile phones, like they have 4 core processors. It means 4 core processors responsible for, you could deploy each and every applications on this one. Okay, so if you check this example, like you have ISP stands for image signal processing unit, and NPU for neural processing unit, and GPU for graphic processing unit, and CPU for central processing unit, and DSP for digital signal processing. Okay, all these are on a single processor package, it available on a single package. So this type of processor is called multi-core processing. Okay, having more than one core on a single package. Most of the mobile phones are multi-core processor or system on chip, like SoC. They like the Snapdragon or system on chip. If the core is same, then it is symmetric multiprocessing. If the core is different, then it is asymmetric multiprocessing. I'll give you one example for asymmetric multiprocessing. It's from Texas Instruments, a processor called OMAP, Open Multimedia Application Platform. And most of the mobile phones are 2014 and 2012, the Nokia mobile phones, they use the same chipsets, but today they use a Snapdragon like quad core processors, and everything is on chip. Like if you check this OMAP, like you have the ARM 11 architecture and you have the TMS DSP architecture. So both are different cores. So TMS DSP, Texas DSP will take care of the audio signal processing and the camera part, everything, and ARM will take care of the touch screen display and other display devices and the GPS and Wi-Fi and Bluetooth and GSM. So everything will be taken care of the ARM processor. Okay, so you have everything is on chip, on a single chip. No need to interface. Like everything is on chip. You could directly connect the connectors like USB connectors and display controllers, display devices, and RTC. Memory card, multimedia card, and GPIO, camera module, everything is on chip. Okay, so this is one example for system on chip. Okay, so coming to ASICs, like how FPGA is different from ASICs, application specific integrated circuits. We have one more kind of device called application specific integrated circuits. If you have the hardware description program language, if you give the hardware description language to the manufacturers like Xilinx or Altera, they will manufacture the chips for your program. Okay, so that is called application specific integrated circuits. That will perform only the specific applications. Like if you take Intel Movidisk, the neural compute stick is one example for ASIC. So and this is possible only if you have large number of quantities. Okay, Antminer, the Bitcoin, Bitcoin miner, Antminer. So these are the ASIC chipsets which will perform only the specific task. Okay, so this is viable only if you have more number of quantities. So if you give the hardware description language to the program to the manufacturers, they will manufacture the chipset only for that program. Okay, so that is ASIC, application specific integrated circuits. So coming to the comparison, like you have microcontrollers. If you want to implement a simple device, simple embedded system design like the door lock kind of thing, you could go with a microcontroller. It has lower performance and lower cost. You could get microcontrollers for 40 rupees. Okay, 40 rupees, 8051 you could get for 40 rupees, and the complex microcontroller can get you for 400 rupees, whereas DSP processor will cost you from 500 rupees to 3000 rupees, whereas system on chip needs more number of volume. Okay, but again you get for 500 to 1000 rupees to 2000 rupees. ASIC is recommended only when you have large number of quantities. Okay, and it has higher performance and low, and the cost will be higher because of its volume. And FPGA, like if you check the pricing for the high cost device, like one FPGA will cost you, or even for 25 lakhs, there are FPGAs available even for 25 lakhs. You could check the cost in a site called digikey.com or digikey.in. And the minimum cost comes from 500 rupees. It starts from the Spartan series, starts from 500 rupees to 600 rupees. And the maximum cost of an FPGA, which is used on satellites, which is used on aircrafts kind of thing, it costs you around 10 lakh rupee and 15 lakh rupee. One chips will cost you around 10 lakh rupee or 15 lakh rupee. You could check the pricing on the digikey.in. Okay, so that's a comparison. Like I will speak, Hemant, I will speak loud. Like give me a moment, let me check my audio. Okay, so I will speak loud. So if you want me to repeat, just Menaka is asking for repeat. If you want me to repeat, just type repeat in the chat box. If you want, if you're clear with the topic, just type clear in the chat box. Just type clear in the chat box. So Rudramani is asking for dinner. You please complete the dinner within 8:30 tomorrow. So we'll have the session from 8:30 to 9:30. Okay. Mohammed is asking for repeat. Okay, so a lot of people is asking for repeat. Okay, I'm waiting for a chat. Kalpesh, thank you. Mohammed, thank you. Shaikh, thank you. Anjali Singh, thank you. Pratimish, thank you. Prakash, thank you. Okay, voice is clear. Thank you so much. Thank you so much. Okay, I'll go with the majority. Please, this video will be there. So we are still running out of time. Like 9:30, we have to close the session, but still we have things to go. but this thing will be available on the YouTube video will be available for 3 more days. So you could go through the video. Okay, so selection of package. Every microcontrollers and DSP processor will come up with a different package. You have to be aware, like you have to choose the right package, because this package needs different kind of soldering equipment. Okay, if you take a soldering iron, which will cost you only 300 rupees to 2000 rupees, the quality soldering iron will cost you around 2000 rupees. If the microcontroller is a dual inline package, the DIP package, okay, the dual inline package, then you could use a soldering iron. If the microcontroller is a quad flat package, like this quad flat package, or small outline integrated circuits SOIC package, or a PLCC package, plastic lead chip carrier, then you need a soldering station to mount the IC. Okay, soldering station to mount the IC. And if the SOC, the most of the SOCs are BGAs, ball grid array. Okay, if you remove the Pentium 4 processor, you could check the pins will be at the bottom of the IC. You might have noted those one. That needs a oven. Okay, that needs a oven to mount. The oven will cost you around like a simple station to mount a BGA will be minimum of 20 lakh rupees. It starts from 20 lakh rupees. You need a stencil to do the job, and the oven will go up to 1 crore rupee to mount the IC. So you have to choose what kind of package. If you choose a SOC, then the package you will be getting only the BGA package, the ball grid array package. You should have a knowledge of doing schematics on BGAs, and it has a complex layout process, and you need also a oven to mount the IC. So you could do, but still, if you could get the job done by assembly house by paying like 1000 rupees for one IC, they will ask you 1000 rupees to just for soldering. Okay, whereas for DIP package and quad flat package, if you practice, you could do it on your own by using a soldering station. Some expert will even do with soldering iron itself. The quad flat package, they will do the soldering iron by using the soldering iron itself. But it's recommended to have a soldering station to control the temperature, because if the temperature, if you give more temperature to this quad flat package chips, definitely that will the IC will that will damage the chip. Okay, that will damage the chip. So you have to choose a selection of package. So coming to the processor selection criteria, okay, you have to choose the first step is to choose the development tools. First, decide what kind of language you are going to use, whether you are going to write the program in C language or ASM language, or you have to decide the IDE, integrated development environment, or hardware description language, or any graphical programming. So the first thing is to decide the development tools. Second thing is to decide the number of IOs you want for the application. How many IOs you need, how many UART you need, how many peripherals you need. Okay, so decide the number of IOs. Decide the speed, what kind of performance you want, whether you are going to do any signal processing, like audio signal processing or image signal processing, and because it needs more speed. The speed depends upon the crystal, the clock frequency you use, because we decide the only the clock decides the speed of the processor. Like if you check a Pentium 4 processor, like 1.5 gigahertz or 2 gigahertz, the speed depends upon the speed, like the clock frequency. Okay, so microcontrollers, some microcontrollers will operate at 10 megahertz, some will operate at 100 megahertz. So more the frequency, more the speed you get. If you want higher performance, you have to go for higher speed. Okay, cost. What is the cost? What is the product cost? If you want to sell within 200 rupees or 300 rupees, then you have to choose a microcontroller with 40 rupees and 30 rupees. Everything the bill of material should be completed within 100 to 150 rupees, like that. Whether you need an operating system, the RTOS, or a simple while loop. Okay, so that you have to decide. And hardware tools, what kind of hardware tools, whether you need a oven, or whether soldering iron is enough, or whether your design contains of a BGA, that you have to decide. And peripherals, what are all the peripherals you want on chip, like the control area. If you want control area networks, like if you want communications for if your application is the automotive applications, then your microcontrollers need the CAN protocol. Okay, so you need a CAN peripherals on chip. And so you have to check whether the peripherals is available on chip. Most of the DSP processor, they will have a specialized audio codecs and video codecs. So that will avoid the complex schematics and complex layouts. Okay, so power consumption, whether it is battery operated, and supply reputations, because when you design a product, the product should be valid at least it should be available in the market at least for 5 years or 10 years, because you have to make profits, you have to make margins. If the supplier discontinues the processors within 1 year or 2 years, then you cannot sell the product after 2 years. You have to redesign it again. So always check with the supplier. So supplier will tell you that if it is not recommended for new designs, they will mention the microcontrollers that NRND. They will have the NRND not recommended for new designs. Okay, so if you design a new product, you have to check whether it has NRND or good to go. Because the product will be available for 5 years of tenure or 10 years of tenure, so that you make more margins on that, profit margins on that. Okay, so these are all the processor selection criteria. If you're clear with this process selection criteria, just type repeat in the chat box. If you want me to repeat, if you are clear, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'm waiting for your chat. Okay, so attendance link is there. Can I use your video to my students? This video will be available only for this free video is Sagar Raja is this free video is available only for 3 days. Okay, so the paid version is very cheap. Like, I'll give you the offer at the end of the session. Okay, you could ask them to attend the sessions on the live chat. We have sessions often. We have 30-day sessions often. You could ask them to attend the sessions, and so that is always welcome. Clear. Thank you so much. And Siraj Rahi is asking for repeat. Okay, and Preeti is also asking for repeat. So rest of the guys are clear, good to go. Thank you so much for Preeti and for Siraj. Please go through this video again. Okay, so already we are running out of time. So coming to the hardware design flow. Okay, so you have the schematic design. Where there are a lot of schematic design softwares available in the market. Like, you have Cadence is one tool which we are going to see. You have a pads designer from Mentor Graphics. You have, and there are like free open sources also there, like Eagle, and lot of tools are there schematic for schematic design. Okay, Altium is there, Altium designer is there. So you have, first thing is you have to draw the schematics. Okay, first you have to bring the schematics, draw the circuit diagram on the software. On that is schematic design. Okay, the next, once you create the schematics, so if you don't have the electronic components, then you have to create the library for that. So some majority of the electronic components, the library will be there. You could take it from the library. If the library is not there, then you have to create the libraries for the schematics. Okay, that is schematic library creation. The second thing is the PCB footprint creation, and you have to do the layout. You have to create the footprints for the PCB, the actual size of the component, and you have to do the layout design. So the first thing is to design the schematics, bringing the circuits to the software, and second is the layout design. Okay, and finally is the PCB fabrication, where you fabricate the PCB and you manufacture the PCB and you assemble and you test the PCBs. Okay, so this is hardware design flow. It contains of schematic design. So there are a lot of schematic design considerations which I'll be covering up on the PCB design sessions on the last 10 days. And the layout design, there are a lot of layout design considerations. We'll be getting much more deeper on the last 10 days of the session. And software design flow is where you once you bring up the board like this. Okay, once you bring up the board like this, the next thing is to write the code for that. You have to decide the integrated development environment. IDE is nothing but it's a combination of the compilers, assemblers, and linkers. Okay, so when you write the code, you will be writing the code on a C language on an editor window. So the compiler will compile the code and translate that to an object file. So these object files will be linked to a linker called a linker is a one which gets the object file and it plays the sections like the program memory on the program sections on the program memory and data memory on the data sections on the data memory, which I'll be covering up much more detail tomorrow sessions, like what is compiler, what is assembler, and what is linker, tomorrow sessions. So, and finally you create an hex file. Okay, the output is a hex format. So that hex format will be downloaded on the microcontroller. So that is the software part through a programmer, or through, you can also sometimes the microcontroller will support over the air programming. You could program through Wi-Fi. You could program through the serial port, or sometimes it needs a special programmers, or through emulators. Okay, so that's the software design flow. Okay, so I just repeat the hardware design flow and software design flow. Hardware design flow, you have schematics where you draw the schematics on the software, and layout design, you create footprints and you do the layout, and finally you fabricate the board. Once the fabrication is done, then you have to write the code for that, okay, by using the editor window. You have to choose IDE, like Arduino is an IDE. Arduino has compilers and linkers, okay. So Kale is a compiler, Scale and Ride IDE. There are a lot of IDEs. Most of the manufacturer will give the IDE. Microchip has MPLab, and the other manufacturers like Texas Instruments has Code Composer Studio, Analog Devices has Visual Studio. Okay, most of the manufacturers, they come up with their own IDE. So you have to choose the IDE and you have to write the code on that. C code, it's embedded C language. Mostly the code will be similar to C language. And finally, you'll get the hex file. Only the hex file will be downloaded inside this microcontrollers. Okay. So apart from this, you have 3 more sections called simulation, evaluation, and emulation. So whenever you design a product, the first thing is to simulate the software. Simulation helps you to reduce the time, and you could also change the components. Simulation is a thing like where there will not be any real hardware. Okay, everything will be in software. You just drag and drop, like Electronic Workbench, Proteus. All these are simulation softwares. MATLAB is a simulation software where you could drag and drop the electronic components, and you wire the components, and you could test the components before you go for the actual real hardware. So that is called simulation. Okay, the evaluation is, once the simulation is verified, that evaluation, most of the manufacturers, they have their own evaluation board, like Pantech manufactures the evaluation board. You could purchase the evaluation boards before going to the actual prototype. So you could purchase the evaluation board, which is the tested one, and you will be implementing the one which you tested on the simulation. Okay, once the evaluation is done, then the actual prototype, the board which you design through PCB layouts and fabricated, that you will be connecting with the IDE through a hardware called emulator. Okay, emulator is which connects the target hardware on the software, where you could download the program inside this target hardware. Okay, so you could keep breakpoints and you could debug. So the manufacturer itself, most of the manufacturer will supply the emulators. Some emulators will be very cheap. You could get for 5,000 rupees and 2,000 rupees. Some emulators will be very costlier, like it will cost you around like even 1 lakh rupee. Like Analog Devices emulators will cost you around 1 lakh rupee or 30,000 rupees. So that is emulation. Okay, so the next thing is the cabinet design. So you could design the cabinets for your embedded system design by using a 3D printer or a laser cutting CNC machine. And test zig, like where you could, if you want to test more than 1,000 boards or 500 boards, then you have to develop the zig, which tests the board, which can download the program by using the pogo pins, and you could write the test codes, and you could wrap it, like you could test 1,000 boards in one single day. Okay, so that's the advantage of going with the zig. You should design this zig so that if you want to manufacture 1,000 boards, more than 1,000 boards, then the programmer should design the zig, and he has to go to the assembly house where the people will test the boards. Okay, so developing of test zig. So is that clear? Just type clear in the chat box. Is that clear? So far, is that clear? Just type clear in the chat box. Okay, so I'm waiting for a chat. Sagar Raja, thank you. Thank you so much. I'm waiting for a chat. Is that clear? Why hex code is required? Why not binary code? Pankaj Sri, like mostly it is of hex format. See, there are different formats, like Xilinx come up with executable linker file format, ELF format, which will be down, only the ELF format will be downloaded inside this FPGA. Whereas 8051, like they download hex format, and like Code Composer Studio, like Texas Instruments, they download out format. Some will be on hex format, some will be on binary format. It depends upon the manufacturers, but mostly it's if you open the file which is going to download it will be on the hex format. Okay, it will be on the hex format. So thank you so much, Rohit. Thank you, Mani. Thank you, Jahmid. Thank you, Graphics. Thank you. Okay, Dev Parma. Thank you. Okay, so how to convert your idea to prototype? Okay, the first thing is to choose the right processor, decide the right processor, and the second step is to choose the right development tool, the right IDE. Okay, integrated development environment. And third step is to design whether your application needs an autos or a simple while loop. works. Sometimes simple while loop works. And choose your package, whether it is BGA or dip package and the production tool. Decide the schematics. Okay, you have to do the schematic design. Consider for DFT and DFM. Design for testing and design for manufacturability. Okay, you have, when you design a product, you have to take care of design for testing. That's the zig one. Okay, so it should have sufficient pins to, for the pogo pins to place, so that you could test the 10,000 boards on one single day, because the mobile manufacturing company manufactures 5,000 mobiles a day or 10,000 mobiles a day. They want to test about 5,000 mobiles in a single day. So they will be considering for the design for testing, like because everything is automated. Okay, design for manufacturing is the one, like it should be, you should be able to manufacture this board easily. The connectors should be, so there are considerations for design for testing or design for manufacturing. That itself is a separate topic. Okay, so layout design. Finally, assembling, debugging, and testing, and enclosure design, and plan for certification if you want, like CE certification or FCC certification. If you want to sell your products on the US markets, then you need FCC certification. If you want to sell the products for the European Union, then you need CE certified. So there are a lot of testing labs available, like India, like Samir is one testing lab is there, like they where you could test, get the test certificates from Samir, and you could apply for certifications for CE certification, FCC certification. That costs you money. And design for test rig for mass production. Okay, so this is how you convert an idea to a prototype. And I'm going to recap. The first thing is to choose the idea and decide applications, decide the applications, decide the right processors, decide the language, decide and fabricate the PCB, and finally integration and testing. Okay, so this is the recap. So we have come to an end, and I would like to give you an offer for the internship. Okay, so we have a 4 months online internship program where we have a detail of embedded system design masterclass for 30 days, where we have covered up 8051 architecture for 5 days, and PIC architecture for 5 days, and norm 7 architecture for 5 days. Every architecture has one sample project on that, and LPC 4088 Cortex M4 architecture for 5 days, and Node MCU for 5 days. So totally 5 projects you get on this course, embedded system design and IoT. And the other courses on Internet of Things, where we covered up 3 major clouds like ThinkSpeak, Microsoft Azure. You have projects on Microsoft Azure. You have projects on Amazon Web Service, AWS IoT. So we have 10 plus projects on IoT Masterclass, that is for 30 days. So where we have each day is for 1 hour video, the 1 hour recorded video as well as the source codes. Apart from this, we have Arduino Masterclass for 30 days, like where it's of Arduino programming, like where we cover up different kind of sensors and different kinds of display device, motors, and robotics and electrical systems and MATLAB. Okay, Arduino, how to program Arduino by using MATLAB. That is for 30 days, and PCB design masterclass for 12 days. Okay, where you could design your own development board. Okay, so all this available, like we have an offer running today. Okay, so those who, we have nearly around 200 people has purchased the 750 rupees offer. For them you will get a link for upgradation. So we have an offer today for just for 999 rupees. Okay, all this 4 course will be valid only, is available only for 999 rupees. The offer is only for today. And those who purchase, the nearly 250 plus students has purchased the 750 rupees course, the single course for 750 rupees. You will get an upgradation link. If you want, you will get an upgradation link for 240 rupees or something, 240 the balance amount, where you could upgrade all this 4 course, and this course will be valid for 1 year, like where you have 102 days of video coaching lessons. Okay, you will be thorough into embedded system design, IoT, Arduino, and PCB design. So you could design your own microcontroller boards, and you have weekend live Q&A session on Zoom platform for 1 year, and internship certificates for 3 months internship, 120 days internship certificates, and 25 plus projects. You could add it to your resume, and you could download the PPTs. You could download the source code, and get the source code download. Everything is available just for 999 rupees, and it's available only for today. If you purchase tomorrow, the Arduino, you will not get the Arduino masterclass. You will get embedded system design, IoT masterclass, and PCB design. You will get only the 3 course if you purchase tomorrow. Okay, if you purchase today, you will get Arduino masterclass. So 4 courses on just for 999 rupees. So it's a massive value. And if you find out this course is not right fit for you, we have a 7 days refund policy. Like you could ask no questions ask refund policy. Like you could get the money back within 7 days if you're not if you find this course is not fit for you. But this course, if you want to make your career on embedded system design, this course is the right fit for you. This 30-day session will be free. Okay, this 30-day sessions will be free, where we will be teaching you 10 days on embedded system design and 10 days on IoT masterclass and 10 days on PCB design. This is the extended version of the 10 days, like 30 days of embedded system design, 30 days of IoT masterclass, and PCB design 12 days. You have live Q&A on every Saturday at 5:30 p.m. on our portal on Zoom platform. Okay, where you could have, if you have any Q&A sessions, we have dedicated forum support for the paid participants. And this money is very cheap for international audience. Like you have the Razorpay link, which we'll be sharing through email. So for the international customers from Nigeria, from Sri Lanka, and from Bangladesh, and from can purchase by using the Razorpay link. Okay, so that will be shared through email. So this course, like you have 1 year access. So every Saturday live Q&A session is there, forum support is there, and free soft skill sessions is also there on sessions by Prasad Ganiraj, like sessions on team building, sessions on time management, sessions on resume building sessions. Everything is available on once you enter into the hub, what is the hub. We have a community. Once you buy this course, you will be signing to the community. Like the community, like you have like I'll show you the community, like where you have free sessions only for the paid participants. Okay, the soft skill sessions. Give me a moment, like I'll show you the community. So you have a community like this, like where you will be having the events. Okay, and uh, where you could attend the sessions. And this community access is only for the paid participants. Like even this Saturday, like we have PCB designing on Zoom platform, and Take Charge Tuesday. Okay, so coaching call with problem solving, and resume building. So you'll be entering in. So this session will be every week. You'll have sessions. So you could also avail this one. Okay, you could also avail this one. So I will take down the Q&A now. Like if you have any questions, you please post on the chat box. Sumit Raj, like the most of this embedded C is there. We have caught up the architecture on 8051 architecture. Like we don't have a basic course on embedded C, but we have given a step-by-step explanation for each and every syntax, which every interface codes which we cover up. Okay, so this 4-day sessions is a recorded sessions, but you could attend the live Q&A sessions on every Saturday. Saturday will be on 5:30 p.m. is live sessions. You could attend the live sessions on Saturday, and you have Take Charge Tuesday. That's on Mindset series from Prasad Ganiraj. That also it's also free. That is at 7 p.m. Okay, so you could attend all the sessions. So if you have any doubts, I'm open to take questions. Like you please go post the questions on the chat box. Okay. Boundmic, like the 4 course will run simultaneously. Like you could watch any course if you want. Like all these are recorded videos. If you have any if you have any clarification, if you want any clarifications or any doubts, we are conducting a live Q&A sessions on every Saturday at 5:30 p.m. on the hub portal. Okay, it is on Zoom platform. Where you could interact with me, you could post your questions, and if you face any problems on the course, you could ask the questions. So I'm waiting for your chat. You could post your questions, and I'm take your questions. Can we switch to Emerson while pursuing mechanical engineering? Gupta is asking for. It depends upon the guts. Like if you do a mechatronics, obviously you could switch over. If you are a pure mechanical engineering, I'm not sure about that. But if you are a mechatronics guys, but still you could switch over. Okay. MicroPython, Mohammed Tariq, we have not covered MicroPython here, but we have a separate course for Raspberry Pi, like, and we have plans to conduct MicroPython on ESP32. But currently we don't have plan now. As of now, we don't have plan. Can you explain more? Visual is asking for, can you explain more difference between FPGA and ASIC? Okay. For this question, this answer is for Visual. Visual Noik, like FPGA is a field programmer get arrays where you could write the program, okay, and you could customize the chip. It's tailor-made chip. Whereas ASIC, if you give the HDL programming to the manufacturer, they will manufacture the IC only for that program, okay, and that will do only that application. That is the application specific integrated circuits, okay. So that is meant only for specific applications. We are also using ASIC on our products. We have a product called BrainSense. It's a EEG headset sensor where we use an ASIC module. The ASIC module is procured from the company called Neurosky. Okay, so they have patented the module. So if you have a patent, if you want to patent the algorithm and if you want to sell it as a chip, then you could give the program. For example, you have speech recognition algorithm, okay, and you want to manufacture, you have written a hardware description language, you have written a code for that. You give the code to the manufacturer, and the manufacturer will make a chip for you, and that chip will do speech recognition. Okay, biomedical device. You could deploy biomedical device ASIC modules for biomedical device for the wearable modules. Okay, the wearable for you could deploy for that. What software is better, microchip or Kale for embedded system programming? Pooja Gupta, like see, actually, like if you ask me, like, don't stick with one micro manufacturer. Like you learn microchip, you learn Texas Instruments. The concept is same, the peripherals are same, okay, everything is same. All you have to do is you have to work on the various compilers, but the concept of IDE, the concept of compiler, the concept of linker, and everything is same. Okay, so my suggestion is for you to, like, you practice Kale, you practice my MP Lab, and you also practice the other CCS Code Composer Studio, like that. Okay, so that will help you. Suresh is asking for Raspberry Pi. There is no Raspberry Pi covered in this course. What is controller? Okay, Shushma is what is controller? It's a microcontroller or a controller. Like it could do only it cannot do a complex mathematical calculations. Like it could do only the control applications, like logic kind of applications, like simple door lock. Okay, whereas the microprocessors and the DSP processors are meant for the complex mathematical calculations. But still, if you check the latest microcontrollers like Cortex M4 series, they all have the DSP capability. They don't want to miss the market. Okay, so they also come up with the mathematical capability. So the latest version of the Cortex M4 series can do the DSP processing, not to a high end, but for a low end applications. Which book is best for embedded system design for beginners to advanced? So Karan Sharma, I will recommend the books on there are a lot of books out there. Like I will recommend the books on the Facebook group. Okay, you please follow the Facebook group. So is that I'm waiting for it questions. Pratiksha is asking, sir, I'm not perfect in coding, so tell me any suggestions. Pratiksha is asking for, I'm not perfect in coding, and tell me any suggestions, right? Pratika, like no one is perfect, like so until you practice. So once you start practice, like practice will make you perfect. Okay. In my early days when I was doing my college, I was not good in programming. We started the company in 2004. We straightly came from college and we don't have any prior experience working on other companies. We straightly started the Pantech solutions. Okay. Today we have more than 300 plus products. It's all in the mindset. Okay. So you could be very, if you love the coding, like you fell in love with the programming, definitely you will learn it. Okay, so first decide what exactly you want. If you want to be a programmer, if you want to be a product developer, product manager kind of thing, or if you want to run your own company, then this skill is very essential for you. If you want to if you want to design your career on embedded system design, then practice will make you perfect. Okay, it's all in mindset. It's all in mindset. People who teach will make you complex. Okay, so if you learn from persons who is making the things simpler, then the programming is very easier for you. It comes by practice. It comes by practice. It's very easy. It's not a rocket science job. Like, it comes by practice, and it's easy to learn. Everyone can learn. Okay. Vignesh, only architecture. How to learn programming? How to learn programming? Okay. Raj Singh, the question is same to you. Like, Raymond is asking, Raymond, I'm failing to pay. Raymond, I'll share you the Razorpay link, because InstaMojo link will not support the international payment gateway. It is not international payment gateway is there. I'll send you an email with Razorpay link, like where you could use PayPal payments. Okay, if you are from South Africa, or if you're from Africa, or from any countries, like if you have PayPal on your country, definitely the link will work. Okay. Manidam sir, may create my own language for specific embedded microcontroller. I'm not sure about this. Sorry, I'm not sure about that. Sir, if you learn PCB design in Cadence Allegro, can we do projects in any other softwares? Tuma is asking for if we can learn PCB design in Cadence Allegro. See, Cadence Allegro is used for designing the product. Okay, it's used for schematic design, for PCB layout design, to fabricate the product. You could it is just to design, is develop your own microcontroller board like this. Okay, if you want to develop your own electronic devices, then this Cadence will help you. There are other tools also, like Altium is there, and uh, is there. I hope I have answered you the questions. Okay. ASIC, Sushmit is asking for difference between ASIC and microcontroller. ASIC stands for application specific integrated circuits, and or like microcontrollers, like it could do only the specific applications, whereas microcontroller, like you could do, you can fit the microcontroller for any kind of applications. Okay. Can we use Java programming in embedded applications? Yes, some supports Java. Some microcontrollers like ESP32 supports Java. Even ARM core processor supports Java. Like, you have to check. Like, there is a term called embedded Java. I have not worked with embedded Java so far. Like, but there's a term called embedded Java, like where this Java can fit on mobile phones as well as for the embedded devices. Okay, MicroPython is there. So WhatsApp group, like Wonder SMS, they will share you the WhatsApp group on the chat box. Okay, the WhatsApp group is shared. Okay. Mechatronics, Rahul, like if you are mechanical, I want to pursue your career in mechanics, mechatronics and automations. Yes, you can opt for embedded system design and robotics course. So this will help you to design your own robotics kind of thing, or embedded plays a major role on robotics. So you could opt in for embedded system design. Uma Shankar, what about CPP? Like, you are asking, Uma Shankar, are you asking about the CPP? I'm not getting your point. C++, you're asking what is CPP? Can you elaborate? Ayush, yes, you will get the certificate once you complete the course. So those who enroll the course for the 4-day internship, the course will be enrolled within 24 hours of time. Okay. So CPLD stands for Sangeet Kumar. CPLD stands for Complex Programmer Logical Devices. So if you have any questions, just post it on the chat box. I'm waiting for your chat. Okay. VLSI stands for Very Large Scale Integration. Okay. For Nomala, Girish. Can be learned using Python programming? Yes, Amar Singh, yes, Python also plays a major role on embedded system design. Like, there are a lot of controllers now come up with Python programming. Like, if you take even the Fpga, like Zinc supports Python programming. Like, they have a pink board, like where you could write the Python programs on the Fpgas. Okay. And NVIDIA, like Jetson Nano, like a Raspberry Pi, those microprocessors, you could use Python programming, like for deploying embedded AI applications on microcontrollers. and DSP processors. Okay. So Raymond, like if you have paid, like the course will be activated within 24 hours of time. So please be patient. Like you could access the course at learn at Pantech. So I will show you that portal. Like you could access at learn at pantechsolutions.net. Okay. So once you make payment, like you could like you could visit this website called learn@pantechsolutions.net, and you could log in with the email ID which you make use for payment. You will get an email once the payment is done. So if you click embedded system design, okay, embedded system design and IoT, like these are all the videos lectures, like day 1, day 2, day 3, day 5. You have the PPTs and you have the UART interface and Bluetooth, and you will also get invitations to join the hub called hub.warriorsway, where we coach you both mindset as well as the uh, uh, mindset as well as the skill set. Okay, so you have sessions like this. So whatever sessions you want, you could attend. Like for example, like February 15, like you have Take Church Tuesday with Prasad Ganiraj, called he is taking a session on problem solving, how to solve your problems. It's a soft skill training. It's free and you could attend. Okay. And this Saturday on February 12th, like we have PCB designing, like how to design schematics on Gerber creation. Like you could attend the session on Zoom platform. So once you make the payment, like you will get 2 invites. One is for the hub, for the community, for the Warriors Way community, and where you will get mindset coaching as well as the skill set coaching, and the learn at pantechsolutions.net, like where you could download the PPTs and source codes. Okay. So you will get, like you have the digital workbooks here for 8051 LPC 214 LPC 4088 pick, and you could ask me any questions on the live Q&A sessions, because I have around 18 plus years of experience on designing the boards. Okay, I will help you to I'm sure that I help you to get most out of it. Okay, the money what you pay is you will get more benefits for just for 999 rupees, and this you will never get anywhere. I'm sure that if you want to make your career on embedded system design, and if you want to design your own embedded products, this course will make a right fit for you. Okay, I'm assured that. And if you feel at any point, like once you buy the course, and if you feel that at any point, like you have taken the wrong decision, we appreciate the decision, and like we give you a refund policy within 7 days. Okay, not more than that. Like if you feel that like this course is not right fit for you, and you could get the money back within 7 days, no questions asked. Okay, so we believe that the value what we deliver is good. Okay, so, Shreya is asking, sir, is there any useful mindful for EC students only, or also triple E students? Washam Seti, like this course is meant for triple E also. Like if you want to learn, if you want, you see there is we have sessions of IoT, like, and we also have motor control applications, like how to control DC motor by using PIC microcontrollers, and so these things you could use DC motor control using PIC. Okay, where we teach you to how to generate PWMs, and we also have plans, but right now there is no, like we also have plans to include how to do a PMS, PMSM motor control, and induction motor control, and 3-phase induction motor control, and stepper motor control, those things to include. But this course, if you are using a DSP processor, because for power electronics applications you will be using DSP processors and microcontrollers. So this course will give you the basics of how to write the code on how to write the code for PWM generation and everything. So that will be definitely, it will be useful for you. Okay. YR is so contributing. See, our vision is to help 10 million students. Okay. We have 10,000 reviews on Google. On if you check our if you check on our the Google, if you check on, I'll show you the Google reviews. Okay, majority are free. Okay, so we give more, like if you check the Google reviews, like currently we have 10,000 reviews. 10,000 reviews. You could go through the Google reviews. Majority of them we give it for free. I will give you like more mindset lessons, because because we strongly believe that 80% of your success comes from mindset. I will tell you the reason why we give free for 30 days. Okay. And we also provide charity, like the lot of things we have as in the system itself, like we have a system for charity itself, like and most of the things like the 30-day sessions is free. It's we shared our own experience, the 18 years of experience, which you will never get free for 30 days. You may get free for 1 day, you may get free for 5 days. I'm sure that, and only the Pantech solutions, the Pantech community, the Pantech is providing 30 days course for free. If you found at any point of time, if you found this you are wasting your time, please feel free to communicate on LinkedIn, and please feel free to communicate on Facebook. We are open on Facebook, okay, on the Facebook group. Please feel free to communicate that that the session is not useful, okay. But definitely, we will recap. But we have conducted the free programs for more than 14 months, like 1+ years, okay. So nearly we have trained nearly 2 lakh plus students so far, and more than 10,000 plus students have submitted the reviews on Google's. So definitely it will be of absolute value, okay. So I also want you to pass this, like you should also give to anyone, like you should also do charity, and you should also spare your knowledge to anyone who deserve that one, okay. But we don't want to give it completely free. We don't want to keep this video completely free, because once you give everything for free, if you keep this video for 30 days, okay, that will not have value. So that we don't want to do this. We will give it, this video will be available on YouTube for 3 days, okay, where you could get a massive massive informations, and you could have a live conversations with me on the chat box, okay. So thank you so much for your time. Thank you so much. See you on the next session tomorrow. Take care, and bye bye. See you on the next class tomorrow. So tomorrow's session is on components of embedded system design. So thank you so much for your time. Thank you. I'm signing off.